Good evening and welcome to your first installment this year of the Flipped Classroom. These are opportunities for you to take notes at home, sometimes do homework, but then go over problems during class that we have just gone over at night to see whether you have mastered that concept. So we're going to be doing two lessons today, lessons 2-5, which talks about properties, and 3-1, which talks about lines and angles. We're going to start with 2-5. That is the only section that we will be doing in Chapter 2. And there are three properties we need to know, so let's start with that. We're going to start with the reflexive property. So you should definitely be putting a box around this. This is a property definition theorem that you would need to know. So you'd be putting boxes around all these things. And the reflexive property says something pretty silly. It says that A equals A. Now, I think anybody could figure out that A equals A, B equals B, C equals C, but there must be some context. And the context here is with the following picture. So hopefully you're looking at this picture and saying there are two triangles sitting there. There is the larger triangle, which contains the top angle all the way top left, bottom left that looks like a right angle, and angle C. And then the smaller triangle, which is clearly inside, and this angle C down here, we would call this the reflexive angle. Why is it reflexive? Because that angle is in both the big triangle and the small triangle. That's called the reflexive property. Next property, called the symmetric property. Says that if A equals B, then B equals A. Pretty simple, and actually we've been using the symmetric property quite frequently and used it probably all of last year. Look at the following algebra problem. 4 plus x equals 5x minus 2. So you subtract x from both sides, add 2 to both sides, get 6 equals 4x. Divide by 4, get 6/4 equals x, except we don't ever say 6/4 equal x. We'd say, well, x equals, well, the opportunity that we have right in here to go from this line down to this line is the symmetric property, the fact that I'm just able to flip that over, and then of course I reduce the fraction from 6/4 to 3/2. That's a symmetric property, being able to flip over an equation or anything that you might need to use. And lastly of the properties is the transitive property. And the transitive property, which is quite important, says if A equals B and B equals C, then, and hopefully you can fill in the blanks there, A equals C. Also have a note down here for you. This property is going to be crucial when dealing with many of our future lessons. A lot of the proofs that we will be coming up with have a lot to do with the transitive property. Moving on to 3-1. These are lines and angles, and the first thing we're going to deal with is parallel lines. Now, we have already talked about parallel lines in this class. You probably talked about them a bunch last year. And if we ever graphed two parallel lines on a coordinate plane, what would you know about them? So you think about it, two parallel lines on a coordinate plane, they have the same slope. The same slope is important because it helps define parallel lines. Those are lines that lie in the same plane and never intersect. Now, having the same plane is very important. I've already created two lines on this plane, on the plane that is this board. They look like they're parallel, but I'm also going to show you right now the parallel mark. You do not know lines are parallel unless you see the following mark. These arrows indicate that you have parallel lines. If you had multiple parallel lines, then just like all the other hash marks we've kind of been using, I'd have 2 arrows, or 3 arrows, or 4 arrows. As long as those are related, then those are parallel lines. Next is skew lines. Skew lines are lines that lie on different planes, should be an S there, and never intersect. And the picture that I've got there is a picture of a prism. And the two lines that I have drawn, line AB, which would be a segment in the prism, and line XV, also a segment, but as you see I have extended them because lines, segments, rays, they can always be interchangeable. Those are on different planes and those would never intersect. So parallel lines and skew lines do not intersect. But there's a very important difference, which is parallel lines are on the same plane, skew lines are not. And last thing we had talked about, actually one of the first days of school this year, is that there are parallel planes. These are planes that never intersect. So if you're looking at the prism from above, that's still in the frame, that's the top and bottom of the prism. Those are parallel planes, or the left and the right, or the front and the back. Those will never intersect one another. Another definition that you need to have is a definition of a transversal. A transversal is a line that intersects two or more lines. So in the following picture, you see I have three lines here. I've got line A, line B, and line C. Which of these is the transversal? A. That's the transversal. That is the line that is intersecting two other lines. And lastly, we're going to get to four more angle pairs. You already know two of them. Two that we had talked about, so we're going to make six. You've dealt with vertical angles and you've dealt with linear pairs. Here are some more. Start with corresponding angles. Corresponding angles are two angles that lie on the same side of a transversal and in corresponding positions at both intersections. Next, we've got alternate interior angles. Alternate interior angles are two angles that lie on opposite sides of the transversal and between the two other lines. So you notice the word interior means inside. The word alternate means opposite sides. And that should help us on the next definition, which is same side interior angles. So we're talking about the same side of the transversal, interior still between the two lines. My definition here are two angles that lie on the same side of the transversal and between the two other lines. Which means that hopefully you can help me define the very last one here, which are alternate exterior angles. Alternate exterior angles are two angles that lie on opposite sides of the transversal and outside the other two lines. Let's look at a picture and make sure we've got this information down. So here are two lines cut by a transversal. Hopefully by now you recognize that line, I'll call it line C over here, is the transversal. The other two lines are being intersected. So the first type of angle we talked about are corresponding angles. There are four sets of corresponding angles in this picture, such as, well, I'm going to start with angles 1 and 8. We said same side of the transversal. Those are both on the left side of the transversal. And they are at corresponding intersection points. So at each of the intersections, they're top left. Which means 2 and 7 are corresponding, 3 and 6, and 4 and 5 are all corresponding. Make sure those are written down in your notes for corresponding angles. Moving on. Next, we will deal with alternate interior angles. Alternate, opposite sides of the transversal, interior, between the two lines. Angles such as 3 and 7. Those are opposite sides and still between the two other lines. So what are the other two alternate interior angles? 4, and 8. Those are alternate interior. Ended up picking the small eraser. Maybe I'll do it better next time. Next set of angles. Same side interior angles. Same side of the transversal. Interior between the two lines. 3 and 8. And what are the other two? Right. 4 and 7 are also same side interior angles. Lastly, we have to deal with alternate exterior angles. Alternate, we've already mentioned, is opposite sides of the transversal. Exterior is outside of the two other lines. Talking about angles like 1 and 5, those are alternate exterior. The other angles there would be 2 and 6. Make sure all this information is written down in your notes. I will definitely be checking that. And the homework that you have to do for tonight, aside from these notes, is the homework from 2-5, which has been posted to Net Classroom. See you tomorrow. Be safe. And one more thing, almost forgot. Go Cowboys!